Hello everyone, today we are going through some important questions of vector algebra. First question, find the sum of the vectors. Vector A is equal to I minus 2j plus k. Vector B is equal to minus 2i plus 4j plus 5k. Vector C is equal to I minus 6j minus 7k. Here we have to find the sum of these three vectors, that is adding these vectors by adding corresponding components, right? So here we have to find vector A plus vector B plus vector C, that is equal to vector A is I minus 2j plus k plus vector B is minus 2i plus 4j plus 5k plus vector C is I minus 6j minus 7k. Add corresponding components. 1 plus minus 2 minus 1 minus 1 plus 1 0. No need to write. Okay. Next is minus 2 plus 4 2. 2 plus minus 6 minus 4j. Next k 1 plus 5 6. 6 minus 7 minus 1 minus k. Okay. So it is the sum of these three vectors. If A, B and C are the vertices of a triangle ABC, then what is the value of vector AB plus vector BC plus vector CA? Consider the triangle ABC. It is vector AB, vector BC, vector AC. By triangular law of vector addition, we can write vector AB plus vector BC is equal to vector AC, right? By triangular law of vector addition. Okay, and we have to find the value of this vector, right? That is vector AB plus vector BC plus vector CA. That is equal to, see here, vector AB plus vector BC is equal to vector AC. So vector AC plus vector CA. And we know that vector CA is equal to minus vector AC, right? Vector CA is equal to minus vector AC. Substitute here. So vector AC plus vector CA is equal to minus AC. So minus vector AC, that is equal to 0 vector. Therefore, vector AB plus vector BC plus vector CA, that is equal to 0 vector. Find the position vector of a point which divides the join of points with the position vectors vector A minus 2b and vector 2 vector A plus b externally in the ratio 2:1. Okay, so here we have to find the position vector of a point. That point divides the join of the points. See, these are the position vectors of these points. Okay, these points. So here that is externally, divides externally in the ratio 2:1. We have already done this problem. That is required position vector is equal to, very simple, required position vector is equal to 2 into 2 vector A plus B minus, it is externally, therefore it is minus. Okay. So 2 into 2A plus B minus 1 into A minus 2B divided by 2 minus 1. That is equal to 4 vector A plus 2 into vector B minus vector A plus 2 vector B divided by 1. Okay. That is here 3 into vector A plus 4 into vector B. It is the position vector of this point. Okay. Find a vector in the direction of vector A is equal to I minus 2j that has magnitude 7 units. See, here we have to find a vector that is in the same direction of vector A, okay, and which has magnitude 7 units, okay. So here we have to find a parallel vector, okay. In the same direction means the parallel vectors. So parallel vectors means, so here one vector should be written in the multiple of, that is scalar multiple of another vector, right. So here we have to find a vector that is in the same direction of vector A and which has magnitude 7 units, okay. So here first of all we will find a unit vector of this vector. Why? Because we know that the unit vector of this vector in the same direction of this vector, right? So here we will find unit vector of A. Unit vector of this vector A, that is equal to vector A divided by modulus of vector A, that is I minus 2j divided by square root of 1 square 1 plus 2 square 4. So vector I minus 2j divided by root 5, that is equal to 1 by root 5I minus 2 by root 5j. Okay. It is the unit vector in the same direction of vector A. Right? Because it is the unit vector of vector A. Therefore, it is in the same direction of vector A. And what is the magnitude of this vector? Since it is a unit vector, its magnitude is 1 unit. Magnitude is 1, right? So here we have to find the vector which has magnitude 7 units and in the same direction of vector A, right? So here the required vector which has magnitude 7 units and in the direction of vector A, that is equal to, its magnitude is 1, okay. So we will multiply by 7, okay. Multiply it by 7 because its magnitude is 1. So 1 into 7, 7. Therefore required vector in the same direction of vector A is equal to 7 into unit vector of this vector A cap, right. That is 7 into 1 by root 5I minus 2 by root 5j, that is equal to 7 by root 5I minus 14 by root 5j. So it is the required vector which has magnitude 7 units and in the same direction of this vector. See here, these two vectors are parallel vectors, right? It is here we can write it in the scalar. See, it is the scalar multiple of this vector, right? Scalar multiple of, see here we can write this vector is equal to, take 7 by root 5 outside, you will get the same thing, that is I minus 2j, right? So here these two vectors are parallel vectors, okay. A vector in the direction of this vector means they should be parallel vectors, okay. Write a unit vector in the direction of the sum of vectors. Vector A is equal to 2i minus j plus 2k. Vector B is equal to minus I plus j plus 3k. Here we have to find a unit vector in the direction of sum of these vectors, means unit vector in the direction of vector A plus vector B. So first of all we need to find vector A plus vector B. Vector A plus vector B, that is equal to 2 plus minus 1, 1, right? I minus 1 plus 1, 0, 2 plus 3, 5. So 5k, okay. So here vector A plus vector B is equal to I plus 5k. Next we have to find the unit vector of, okay, in the direction of vector A plus vector B, that is equal to, here we know that unit vector of vector A is equal to vector A divided by modulus vector A, right? So here unit vector of vector A plus vector B is vector A plus vector B divided by modulus of vector A plus vector B, okay. That is equal to I plus 5k divided by root of 1 square 1 plus 5 square 25. That is equal to 1 by root 26I plus 5 divided by root 26k. So it is the unit vector in the direction of sum of given vectors. Vector A is equal to 7i plus j minus 4k. Vector B is equal to 2i plus 6j plus 3k. Then find the projection of vector A on vector B. Very simple. Our formula is here projection of vector A on vector B. Scalar quantity, not projection vector. Projection of vector A on vector B. So here projection of vector A on vector B, that is equal to vector A dot vector B divided by modulus of vector B. That is equal to vector A dot vector B is 7 into 2, 14 plus 1 into 6, 6 plus minus 4 into 3, minus 12 divided by modulus of vector B, that is square root of 2 square 4 plus 6 square 36 plus 3 square 9. That is equal to 14 minus 12, 2, 2 plus 6, 8 divided by root of 49, that is 7. So 8 by 7 is the projection of vector A on vector B. If vector A and vector B are unit vectors, then what is the angle between vector A and vector B, so that root 2 vector A minus vector B is a unit vector? See, here we have to find the angle between two vectors, vector A and vector B. Given conditions are vector A and vector B are unit vectors and root 2 vector A minus vector B is also a unit vector. Okay. We have a formula cos theta is equal to vector A dot vector B divided by modulus of vector A into modulus of vector B. What are the values of modulus of vector A and modulus of vector B? Since vector A and vector B are unit vectors, their magnitudes are 1, right? Therefore, it is equal to vector A dot vector B, because it is 1, it is 1 into 1, 1. Since vector modulus of vector A is equal to modulus of vector B is equal to 1. Okay. Therefore, cos theta is equal to vector A dot vector B. And one more condition, root 2 vector A minus vector B is a unit vector. That is, its magnitude is 1. Right. That is modulus of root 2 vector A minus vector B is equal to 1. That implies modulus root 2 vector A minus vector B square is equal to 1. This can be written as by scalar product of two vectors. Here root 2 vector A minus vector B dot root 2 vector A minus vector B. Right? Expand this, that is equal to 1. This implies root 2 vector A dot vector A. Root 2 into root 2, 2. 2 into vector A dot vector A, 1. Right? Next, minus root 2 into 1, root 2, vector A dot vector B. Vector A dot vector B. Next, minus 1 into root 2, minus root 2, vector B dot vector A, that is nothing but vector A dot vector B. Okay? Vector A dot vector B is equal to vector B dot vector A. Okay? We know that scalar product of two vectors is commutative. Okay? So here root 2 minus 1 into root 2 minus root 2, vector B dot vector A can be written as vector A dot vector B. Okay? Minus into minus plus vector B dot vector B is 1. Right? 1. That is equal to 1. Okay? That implies here 2 plus 1, 3. Take this 3 right side. So here minus root 2 minus root 2, that is minus 2 root 2 minus 2 root 2 vector A dot vector B, that is equal to 2 plus 1 3. Take this 3, 1 minus 3, that is minus 2. So minus minus cancelled. This implies vector A dot vector B. Take this one here. So it will be vector A dot vector B is equal to 1 by root 2. Okay. And we have vector A dot vector B is equal to cos theta. Cos theta is equal to 1 by root 2. Then what is theta? Theta is pi by 4. Right? Theta is equal to pi by 4. Write to the value of lambda so that the vectors vector A is equal to 2i plus lambda j plus k and vector B is equal to I minus 2j plus 3k are perpendicular to each other. We know that scalar product of two perpendicular vectors is 0, right? Because its angle is 90 degree and cos theta, cos 0, cos 90 is 0, right? So here we can write, since vector A and vector B are perpendicular to each other, dot product of, that is vector A dot vector B is equal to 0, right? Because vector A dot vector B is equal to modulus of vector A into modulus of vector B into cos theta, right? When these vectors are perpendicular to each other, its angle is, that is angle between vector A and vector B is 90 degree. Cos 90 is 0, right? Therefore, scalar product of two perpendicular vectors is 0. Therefore, here we can write vector A dot vector B is equal to 0, right? Vector A dot vector B is 2i plus lambda j plus k dot I minus 2j plus 3k, that is equal to 0. How to find the scalar product? 2 into 1, 2 plus 2 into minus 2 lambda plus 1 into 3, that is equal to 0. Okay. That implies here 5 minus 2 lambda is equal to 0. That implies lambda is equal to 5 by 2. If vector A and vector B are two vectors such that modulus of vector A dot vector B, that is equal to modulus of vector A cross vector B, then find the angle between them. Okay. So here let theta be the angle between vector A and vector B. Okay. And it is given that modulus of vector A dot B is equal to modulus of vector A cross vector B. So here we have formula modulus of vector A dot vector B is equal to modulus of vector A into modulus of vector B into modulus of cos theta, right? And modulus of vector A cross vector B, that is equal to modulus of vector A modulus of vector B modulus of sin theta, right? Okay, so equate this. It is given these are equal, therefore modulus of vector A dot vector B, that is equal to modulus of vector A cross vector B, that implies modulus of, it will be cancelled, right? Vector A modulus of vector A modulus of vector B modulus of vector A modulus of vector B, that will be cancelled. Okay, so remaining modulus of cos theta, that is equal to modulus of sin theta, right? That implies, take this sin theta here, it will be, okay, take cos theta there, okay, so it will be modulus of tan theta, that is equal to 1. So that implies modulus of tan theta means tan theta, that is equal to 1. That implies here theta is pi by 4. Tan pi by 4 is 1. Therefore, angle between vector A and vector B is 45 degree, that is pi by 4. Vectors vector A, vector B and vector C are such that vector A plus vector B plus vector C is equal to 0 and modulus vector A is equal to 3, modulus vector B is equal to 5, modulus vector C is equal to 7. Then find the angle between vector A and vector B. So here let theta be the angle between vector A and vector B. Okay. And the given condition is vector A plus vector B plus vector C is equal to 0. That implies vector A plus vector B is equal to minus vector C. Right? Take modulus on both sides. So, modulus of vector A plus vector B, that is equal to modulus of minus vector C. That implies here modulus of minus vector C, that is equal to modulus of vector C. Right? Modulus of minus vector C is modulus of vector C. Right? Their magnitudes are same. Right? Modulus means it is always positive. Okay. Then that implies take square on both sides. So, modulus vector A plus vector B square is equal to modulus C square. Okay. Then what is it? By scalar product of two vectors, this can be written as vector A plus vector B dot vector A plus vector B. Right? That is equal to modulus of vector C square. That implies, expand this, vector A dot vector A is modulus of vector A square. Right? Vector A dot vector A, that is equal to modulus vector A square plus 2 into vector A dot vector B plus vector B dot vector B is modulus vector B square, that is equal to modulus vector C square. And these values are given. Modulus of vector A, modulus of vector B and modulus of vector C are given. Substitute these values. It is modulus of vector A is 3 square 9 plus 2 into, here also this can be written as, apply the formula, vector A dot vector B is modulus of vector A into modulus of vector B into cos theta. Right? So, modulus of vector B A is 3 and modulus of vector B is 5 into cos theta plus modulus of vector B square, that is 25, is equal to 7 square 49. That implies here 2 into 3, 6 into 5, 30. So, 9 plus 25, 34. So, 34 plus 30 cos theta, that is equal to 49. Take this 34 right side, that implies 30 cos theta is equal to 49 minus 34, that is equal to 15. That implies cos theta is equal to 15 divided by 30, that is equal to 1 by 2. Cos theta is equal to 1 by 2. Then what is theta? When cos theta is 1 by 2, cos 60 is 1 by 2, right? That is pi by 3. That implies theta is equal to pi by 3. Therefore, angle between vector A and vector B is pi by 3, that is 60 degree. If the sum of two unit vectors, vector A and vector B, is a unit vector, show that magnitude of their difference is root 3. Here it is given vector A and vector B are unit vectors and their sum is also a unit vector. Okay. So here we can write A cap, okay, vector, that is unit vector A cap plus B cap, that is equal to C cap. Sum of these unit vector is again a unit vector. Okay. Then take modulus on both sides. Modulus of A cap plus B cap is equal to modulus of C cap. Okay. Then take square on both sides. This implies modulus of A cap plus B cap square is equal to modulus of C cap square. That implies here by scalar product of two vectors we can write it as A cap plus B cap dot A cap plus B cap. That is equal to, what is the value of this one? Since it is a unit vector, the modulus of C cap is 1. 1 square is 1. Right? Expand this LHS. A cap dot A cap. Okay, here we know that vector A dot vector A is equal to modulus of vector A into modulus of vector A into cos 0, right? Since these are same vector, so angle is 0. So it is equal to modulus of vector A square. Since it is a unit vector, its value is 1, right? That is magnitude is 1. Therefore, A cap dot A cap is 1 plus 2 into, see, B dot b cap dot a cap plus a cap dot b cap. Okay, that is equal to 2 into a dot b. Okay, plus b dot b, that is also 1. Since it is a unit vector. Okay, b cap dot b cap, that is also 1. Okay, that is equal to 1. This implies 2 into a dot b is equal to 1 plus 1, 2. Take this to right side. So 1 minus 2, that is minus 1. And here we have to show magnitude of their difference is root 3. That is, we have to show magnitude of a cap minus b cap is equal to root 3. Okay, so here let's find modulus of a cap minus b cap square. Okay, that is equal to a cap minus b cap dot a cap minus b cap. Expand this. A dot a, that is all 1, since it is a unit vector, minus 2 into a dot b, okay, plus here also b dot b, that is also 1, that is equal to 1 minus, here what is 2 into a dot b, that is minus 1, right? So minus 1 plus 1, that is equal to 3. See here, we have got modulus of a cap minus b cap whole square is equal to 3. Then what is modulus of a cap minus b cap? That is root 3. Right? Therefore, magnitude of their difference is root 3. If vector A is equal to 2i minus 3j plus k, vector B is equal to minus I plus k, vector C is equal to 2j minus k are 3 vectors, find the area of the parallelogram having diagonals vector A plus vector B and vector B plus vector C. See here, we know that we have a result. If vector A and vector B represents the adjacent vectors, then adjacent vectors of a parallelogram, then area of the parallelogram is modulus vector A cross vector B. Right? But here two diagonals of the parallelogram is given. Okay, two diagonals of the parallelogram are given. So here let's take vector D1 and vector D2 are the diagonals of this parallelogram, and vector A and vector B are the adjacent vectors. Okay, it is given vector A plus vector B is one vector. So by the triangular law of vector addition, here we can say it is the vector A plus vector B and it is vector B plus vector C, right? So here by some derivation of this cross product, that is D1 cross D2, vector D1 cross vector D2, here we will get 2 into vector A cross vector B. Okay, by applying some properties, that is a triangular law of vector addition and the derivation of a cross product, here we will get D1 cross D2 is equal to 2 into A cross B. Okay, here D1 is vector A plus vector B and D2 is vector B plus vector C. Okay, so here what is the modulus? Modulus of vector D1 cross vector D2 is equal to 2 into modulus of vector A cross vector B. That is, here we have to find the area of the parallelogram using these diagonals, right? So here vector modulus of, we know that area of a parallelogram is equal to modulus of vector A cross vector B, right? So that is modulus of vector A cross vector B is equal to 1 by 2 into modulus of D1 cross D2. Okay, so that is, here we have to find D1 and D2. That is vector A plus vector B, vector B plus vector C. So let's find vector A plus vector B. That is equal to, add these vectors, 2 plus minus 1, 1, that is I, minus 3 plus 0, coefficient of j is 0, so 3 minus 3, j, 1 plus 1, 2, 2k. Okay. Next let's find vector B plus vector C. Vector B plus vector C, minus 1 plus 0 minus I, 0 plus 2, 2j, 1 plus minus 1, 0. Okay, so here these are the diagonals of this parallelogram. Okay, Therefore, our area of parallelogram is equal to 1 by 2 into modulus of d1 cross d2, right? That is vector A plus vector B cross vector B plus vector C. Okay, that is equal to, here we have to find vector A plus vector B cross vector B plus vector C. Okay, so let's find it. Vector A plus vector B cross vector B plus vector C, that is equal to determinant I, J, K, 1, minus 3, 2, minus 1, 2, 0. That is equal to I into 0 minus 4 minus J into 0 minus 2, 0 plus 2 plus K into 2 minus plus 3, that is 2 minus 3, 2 minus 3, that is equal to minus 4i minus 2j minus k. Okay, and find its modulus value, that is modulus of vector A plus vector B cross vector B plus vector C, that is equal to square root of minus 4 square 16 plus 4 plus 1, that is equal to square root of 21. Okay, so here what is the area of parallelogram? 1 by 2 into modulus of vector A plus vector B cross vector B plus vector C, that is root 21 divided by 2 square units. Vector r is equal to xi plus yj plus zk. Find vector r cross I dot vector r cross j plus xy. Okay, so here we have to find vector r cross I dot vector r cross j plus xy. Now substitute vector r. Vector r is equal to xi plus yj plus zk. So xi plus yj plus zk cross I dot vector r xi plus yj plus zk dot j plus xy, that is equal to, here xi cross I, that is x into I cross I plus y into j cross I plus z into k cross I dot x into I cross j plus y into j cross j plus z into k cross j, okay, plus xy. Again next, here we know that I cross I is 0, right? So this one 0. Y into j cross I. Y into j cross I cross j is k, right? J cross I is minus k. So minus yk plus k cross I is j. So zj, okay, dot x into I cross j is k, xk plus it is 0, right? J cross j is 0. Next is, see here k cross j is minus I, okay, j cross k is I, k cross j is minus I, therefore it is minus zi plus xy, okay. That is equal to, okay, now let's find the dot product, scalar product of these two vectors. So first of all, corresponding components, okay, we have to multiply corresponding components. So be careful. here first of all, okay, let's multiply I. Okay, here I is 0. 0 into minus z, that is 0. Okay, 0 into here no I, therefore 0. 0 into minus z, 0, plus next j, z into here no j, okay, that is 0. Z into 0, 0, plus next k component, k coefficient minus y into x, that is minus xy. Okay, plus xy. Minus xy plus xy, that is equal to 0. Okay, therefore vector r cross vector I dot vector r cross j plus xy, that is equal to 0. If vector A is equal to I plus j plus k and vector B is equal to j minus k, find a vector C such that vector A cross vector C is equal to vector B and vector A dot vector C is equal to 3. So here given vectors are vector A is equal to I plus j plus k and vector B is equal to j minus k. Then let vector C is equal to xi plus yj plus zk. We have to find the vector C, right? So here let's take vector C is equal to xi plus yj plus zk. So here we have to find the values of x, y and z. Okay, and it is given A cross C is equal to B. Let's find the cross product of vector A and vector C. So vector A cross vector C is equal to vector B. That implies vector A cross vector C is I j k 1 1 1 x y z. That is equal to, what is vector B? J minus k. Okay, that implies here I into z minus y minus j into z minus x plus k into y minus x, that is equal to j minus k. Here these two vectors are equal vectors, therefore their corresponding components are equal. Okay, so here coefficient of I is z minus y, here coefficient of I is 0, therefore z minus y is equal to 0. Okay, and minus of z minus x, that is x minus z. X minus z is equal to, here coefficient of j is 1. Okay, next is coefficient of k is y minus x, that is equal to coefficient of k is minus 1. Okay, then and one more is given, that is one more condition is given, vector A dot vector C is equal to 3. Okay, vector A dot vector C is equal to 3, that implies vector A is this one, vector C is this one, right? So find the dot product. 1 into x, x plus 1 into y, y plus 1 into z, z, that is equal to 3. Now let's substitute these values here. Okay, means see, let's make it in the form of, that is in terms of x. Okay, so here x plus, let's substitute what is y, we will get it here. Okay, so y is equal to, take this x here, so we will get x minus 1. Okay, y is equal to x minus 1 plus what is z? Z is equal to x minus 1, right? X minus 1, that is equal to 3. That implies x plus x plus x, 3x. 3x minus 2 is equal to 3. That implies 3x is equal to 5. That implies x is equal to 5 by 3. Okay, we have got value of x. Next we will find the values of y and z by substituting these x values in this equation. Okay. So here we know that y is equal to x minus 1, right? So that is 5 by 3 minus 1, that is 2 by 3. Okay, and z is also is equal to, see from this equation, z is equal to x minus 1, that is equal to 5 by 3 minus 1, that is also 2 by 3. Okay, now we have got values of x, y and z. Then what is vector C? Required vector C is equal to xi, that is x is 5 by 3 I plus y is 2 by 3 j plus 2 by 3 k. So it is the required vector.